Hi, welcome to the video on kinetic and potential energy word problems practice. So in this video, I'm going to go over what we went over in class, and then there'll be some practice problems for you to do on your own. So in the beginning, this slide goes over the key information for kinetic and potential energy. So when you are dealing with these word problems, the first thing you need to do is read the problem and identify if it's a kinetic problem, kinetic energy problem, or potential energy. And we know it's kinetic energy if the object is moving. So if there's movement, it's kinetic energy. And of these blue boxes, the right equation for kinetic energy is this one, 1/2 times mass times velocity squared. So we're going to move that box here. You can delete the other kinetic energy equation because that is not the correct equation for kinetic energy. Now, if the object is not moving, it's potential energy. And for that, we use this as the correct equation for potential energy. Mass times g, which is a constant, 9.8, times height. So mass times 9.8 times height, that is the equation we use. And this one we can delete as well. Okay, now let's go into the units. Now, the other thing is, once you've figured out if you're doing potential energy or kinetic energy, then you have to find the variables, the known variables in your problem, so you can plug it into the equation. The best thing for us to do is to know the units that we need to be using. That's also helpful in more challenging problems where the units that they give you are incorrect, so you also have to know that you need to convert them to the correct units. So what are the units that we use? For mass, whether it's in kinetic or potential energy, the units for mass are kilograms. So just go ahead and move that box here, and the symbol for kilograms is kg. The height will be in meters, so we're going to move this box here, and the symbol for that is m. The velocity is meters per second, m/s. And energy will be in joules. So if your mass is in kilograms, your height is in meters, your velocity is in meters per second, then energy will be in joules. Once we've identified our givens and what we're asked to find, then we'll plug in to solve. Let's look at a couple examples where we can see how we figure out what we're dealing with, if it's potential and kinetic energy, and then what are identifying our givens and finds. So in this example problem, it says calculate the energy of a 75 kilogram piano hoisted on a crane 20 meters above the ground. So the first thing you have to ask yourself, am I dealing with potential or kinetic energy? And the only way you can know that is if the object is moving. But here it's just being hoisted, it's just suspended in air, it's not moving. So for that, we know that it's potential. So we're going to take this box and delete it. It's not kinetic, it's potential. So this is the right equation. And the potential energy equation is mass times g, which is a constant, 9.8, times height. So the two variables, known variables we need here is mass and height. So let's start off with the 75 kilograms. When you see kilograms, what is that? Mass or height? That is, of course, mass. So whenever you see kilograms, that's a unit. The number in front of that is your mass. The height will be in meters, so that's 20. So we're going to drag and drop that here. So if we wanted to solve this problem, what we would do is we would do 75 times 9.8, which is g, times 20. Let's go to our second example. In our second example, we would determine the energy of, we're asked to determine the energy of a 1,000 kilogram roller coaster that is moving with a speed of 20 meters per second. So once again, I got to figure out, hey, is this kinetic or potential? How do I know that? Is it moving or is it not moving? Well, clearly the roller coaster is moving. It even says it in the problem. So if it's moving, that's kinetic. So I'm going to take the potential energy equation and delete that. And I'm just going to move that over just so it's in the center here. You don't have to do that. But this is the equation that we're going to be using. Kinetic energy equals mass times velocity squared. So that means there's two variables, once again, I need to find in here. The first one being mass. It's 1,000 kilograms. Remember, the number in front of kilograms is your mass. And your speed has a unit of meters per second. So that's your v. So I'm just going to plug that in here. Okay. So once again, if I actually were to solve this, I would plug these numbers into this equation. Now, on this slide, it has Quizlet, which goes over some of the terms or things like that. You can do this on your own. I won't be looking at that. We're now going to go into example problems. This is broken down into three parts. Part 1 just has all kinetic energy problems. Part 2 has all potential energy problems. And part 3 is a mix, so this is where you're going to have to decide what you're doing. Now, in these problems, the way that you show your work is you are are given, you'll see in this example here, you're given the word problem, and then I actually provide the equation for you, because it really is about also helping you to substitute things in and to practice utilizing the equations, because sometimes it can be a bit tricky. So let's look at this first example. The velocity of a car is 65 meters per second, and its mass is 2,515 kilograms. What is its kinetic energy? So they're telling us it's kinetic energy, so in this case, we don't even have to think about what equation it is. An equation, for the kinetic energy is 1/2, which is the same as 0.5, so that's what is there, times mass, that's what that m is, times velocity squared, v times v. When you're squaring something, you're multiplying it by itself 2 times, and so I wrote that out this way. You could, of course, utilize a calculator and use the square function on the calculator, but in case you didn't have it, this is what it is. Now, how do you show me your work? And this is important. You won't get full credit if you're not doing this show your work. To show your work, you have to drag and drop, you see these boxes with the numbers, into the right part of this equation. So in this problem, the first number I see is 65 meters per second. Well, what is that? If you go back to the slides on units, whenever you see meters per second, that means it's velocity. So meters per second is velocity. So going back to our problem here, this number, since it says meter per second, is my velocity. So that's where I'm going to plug this in for v. So you're going to drag and drop the 65. Now we have the mass, which is the other one I need to do. Wherever I see kilograms, I know that the number in front of that is my mass. So I'm going to plug that in here. So this is the math I have to do. 0.5 times 2,515 times 65 times 65. Go ahead and do that on a calculator. Okay, so this is what I have. I'm going to plug this into the calculator. 0.5 times 2,515 times 65 times 65. Or I could just do 65 squared. And when I plug that in, I get this huge number. So this is the number that I'm going to enter into the red box. That's where you're going to put your answer. Okay, and then I'm going to put joules. Okay, and I'm going to add some commas so you can see that this is 5,312,937.5 joules. Don't forget the units, joules, or you'll lose points. All right, so that's how you do that. Let's look at this another problem. If a 30 kilogram child running at a rate of 9.9 meters per second, what is its kinetic energy? So in this case, once again, we know it's kinetic energy. 30 kilograms, where do you think that goes? Is that the mass or velocity? Well, if it has kilograms behind it, that number is our mass. So we're going to plug that in here. And running at a rate 9.9 meters per second, that is the velocity. So I'm going to do that twice. And you can go ahead and do the math. 0.5 times 30 times 9.9 times 9.9. And that'll give you. So I get this number here when I plug that into the calculator. And I'm going to just go ahead and copy and paste it. And so this is the answer for that. All right. There's one more problem for you to do on your own. So on slide number 9, you can do this problem. Make sure you show your work by dragging and dropping the boxes into the correct part of the equation. Put your answer here and don't forget the units. Once you've done that, we're going to look at some potential energy word problems. So now this is part 2. For potential energy, that's when the object is not moving. So look at this example. A brick is suspended above the ground at a height of 6.6 meters. It has a mass of 5.3 kilograms. What is the potential energy of the brick? And they give us G, which is a constant. It's 9.8 if you're on Earth, meters per second squared. So what we need to do is, again, just drag and drop. So potential energy is mass times G, 9.8 times height. So let's start off with, let's see if we can find our mass. Let's do it that way. Which of these numbers is our mass? We have 6.6 m, 5.3 kg. Now, some people will see this m and think, oh, I'm just going to drop that here. Remember that when the letter comes after the number, it is meters. So that m is meters, so that's not the correct one. Meters is used for height. So the 6.6 will go here. The mass is 5.3, so because there's a kilograms after it. So that goes here, and then we plug in the 9.8. So all we got to do now is calculate to solve. Okay, so we plug that into the calculator, and we get this as our answer, 342.804. And don't forget that unit there, joules. Don't forget the unit for energy is joules. Now you can try the problem on slide 12. Once you've done that, the rest are mixed problems, and you're going to do all of these on your own. Fortunately for you, I give you the equation, so you don't, and I also tell you you're calculating PE or KE, so you don't have to do that part of deciding what it is based on whether or not it's moving. But what you do have to do is make sure you drag and drop the numbers into the correct places. Now, couple of things. On slide number 3, in this case, you have to consider that it's a girl riding a bike, and you're asked to get the total mass. So whatever the mass of the girl is, plus the mass of the bike, that will give you the total mass. You're going to type that number in here, okay, whatever the total mass. And then you'll drag and drop this. So let's say the total mass was on 100. You would type that in. Then you would drag and drop this box in for the mass. That's what you would do, okay? So drag and drop the mass of the bike and the girl onto these lines. Calculate the total mass. Type that number here, and then drag and drop that box for the mass. All right. The other thing I wanted to point out, slide number 4 talks about a rock that's on a cliff. The mass of this rock is 4,812 kilograms. In subsequent problems, like in problem slide number 5, you're using the same rock that's on slide number 4. So the mass of this rock, to get the mass, you go back to slide 17, so starts to take question 4, and you would copy that and use that here for number 5, okay? For slide 5. There's one more time you have to do that as well. Slide 20, so question number 7. Again, it's the mass from problem 4, so the mass hasn't changed. So you need to copy and paste that same mass from question 4 here. The height for this question, going back to question 7, the height, they're telling you that boulders are at the bottom of the hill. So you have to type in what you think the height is if it's at the bottom, and then move that number in for the height. That's it. Once you've done those, you can submit. Slide 21 just has just what I said about using the same mass for question 4 as for question 5 and question 7. So that's what that is. So you don't really need that, but if you need, you can look at it. And these are extra cards in case you happen to delete some numbers and you need to go find a number to drag and drop. They're here, but you don't need these slides. You just need to make sure you get the mixed practice done. Part 3 done. Any of the question on slide 12 in part 2 we didn't do, and the question on slide 9 we didn't do. All right, I hope you found this video helpful in completing these problems. Have a quality day.